The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. The Sporlan S3C series of case control products provides safety, security, and service for remote and self-contained refrigerated display appliances. The S3C family of controls includes a case controller, display module, and a valve module that all support open protocol communication via BACnet and Modbus. The peer-to-peer system is capable of standalone or coordinated control of up to 8 refrigerated cases per lineup. Using this family of controls simplifies and shortens the time required to set up new equipment or retrofit an existing system. Ask your local refrigeration wholesaler about the Sporlan S3C series. Parker Sporlan, leading the charge.
This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer oil float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model. Conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. Your host, Brett Wetzel and Kevin Compass. How are you doing today?
I'm stuck down this rabbit hole that you threw me down of trying to make this defrost scheduler, and it's consuming like all my free time. Thanks.
No, so you're the one who called me.
Yeah.
And no, hold on. Let me just clear the air here, because you were like, it'd be really cool if we could figure out a way to do it. And then I worked on it for 6 hours, and then I explained what I was doing in order to achieve this. And then you're like, then you just ran with it.
Yeah. And then now I'm like hours, like 15 hours deep into this.
Excuse me. No, I know it sucks because how many times have you had to redo the whole thing?
Like I'm on like try number 7 and I'm almost there. And then I tweak it a little bit and it just falls apart.
Yeah. No, I've been there. Mine fell apart, I think 3 times. And I'm just like, fuck this, I'm done with it. I'm not, I don't know.
I'm almost there, but it's looking so good. And it's going to save me so much time. I guess it's worth it.
Why don't you share it?
Like it's done yet.
So what if it's not done? Whatever you have done, unless they go through the 15-hour rabbit hole, they're not going to figure out like how you did it. It was actually your idea. You're like, we should do this and give it away to everybody. Now you're like, I don't want anyone to know.
Yeah, it's still running code in the background, so it's not there yet. It's almost there. So what are we talking about tonight?
I don't know. I thought we'd do communication issues.
Okay.
I don't know, just regular communication issues. We could start with something like an S3C, right? That runs, like I said, 485 first, and then goes up through basically starts with 3-wire and then goes to the Ethernet, because we've been talking about it a little bit, but I figured we'd just elaborate on that, because there are some people that don't understand that.
Let's hit it. Then we'll bring in some SC3 or some CC200 stuff, because it shares a lot of similarities with that, and there's a lot of testing stuff you could do with it.
So when I start any kind of communication issue, and I know you're going to gawk at me as soon as I say this, but usually what I'll do is try to find the actual wiring and try to get it to the way that it was originally designed. Start with seeing it, because it gives you an idea of like where everything is ran to. Unfortunately, sometimes you can have one shorted wire and it could potentially take down the whole system. Like back when we used to use Echelon a lot with CPC, you could have one shorted wire and it would take out all the rest of the controllers. They would just kind of start sitting there and resetting. And at that point, you just start from scratch and you unplug everything and then reset the E2. And then just if you have multiple COM ports coming out of that unit with the splitter, or actually they call it a repeater, you just plug one in at a time and keep going away and keep plugging them in until it fails out. With a lot of the case controllers, if you have a shorted wire, it could be bad, but not really bad where it actually takes it out, takes the actual PIB board out. And the only time I've ever seen that is typically when you have one of the case controllers that pulses voltage on the bipolar stepper and then basically juices the PIB board.
Yeah, I've seen the same thing. It's the LAN stuff is the same for microthermal too, like troubleshooting it. And the LAN stuff also, it's very important that your ohms on your network.
Yeah, and I know we were going to talk about the other one, but why don't we talk about LAN for a little bit, since we do there's still a fair amount of Echelon and the microthermal stuff. So like my understanding, it was supposed to be like 56 or 53 ohms or something like that. But I didn't realize that most of the time when you're checking that resistance, you're having to actually unplug all the boards. But in microthermal's case, you actually have to keep the wires plugged in, correct?
Correct. You want to do it with it plugged in, and you want to check it middle and in a couple other spots. You should have anywhere from 52 to 58 ohms. Like, obviously 56 is like perfect.
No, all I was going to say is, so that'll tell you if you have potentially the right wire. Microthermal is very finicky on like making sure you actually have the right style of wire, which is really going to affect those ohms.
I have found a couple things with this. Like, I have got my ass handed to me on this. Either Belden or West Penn is the only thing I'll use. Like, personally, I prefer West Penn 225. Some customers don't allow it. It's easier to work with. The coating is not as thick on it.
Mm-hmm.
And I honestly think it has less problems. But Windy City Wire, I refuse to use it. Any job we've used Windy City Wire at, I have nothing but issues at. And that's the same wire. You guys had the same issue with the wire in Arizona. You and James did. It was Windy City Wire.
Yeah, but it wasn't the exact number that they wanted you to use, though, if I'm not mistaken.
It was one of the acceptable alternatives is what you had.
Really?
So, but like anytime we've used Windy City Wire, we have issues. Personally, I have good luck with West Penn. It's a quarter of the price. Like a roll of Belden cables, like over $1,000.
It ain't cheap.
No. For 16.2 Belden cable. And my biggest problem with the Belden cable is it's so thick, like 2 passes will eat up a 1/2-inch knockout.
Yeah, no.
So it's extremely difficult to run it. And it puts a lot of stress on the wire connectors, especially at like cases and stuff. It seems to put a lot of stress on everything. So I don't like using it.
Stop messing with the Excel sheet.
God damn it.
Put it down for 2 seconds. I can tell you're totally not focused at all. It's killing you. I know it's killing you inside.
Yeah. All right. I hate you. So honestly, it's so thick that it's difficult to work with. And it's a pain in the ass to pull. So I prefer the West Penn. It's a little bit thinner on the shielding, but I've had good luck with it.
Gotcha.
My ADD is just going.
Yeah, I know. It sucks. Get over it. Thermal is one of the only ones, like with CPC, they'll tell you that their Echelon network needs to be in a straight daisy chain. But with the microthermal, they're like, oh, yeah, stars are cool.
Stars are better.
Which is confusing. Probably the only reason why is because most of the stores are huge and you have to hit so many nodes, right?
So, yeah, like a CO2 store may have 175 nodes. So that's 175 boards on one day, on not one daisy chain or one chain, it's multiple chains. But at the same time, the more you star, the better off quality comm you're going to get. So that's the big thing with microthermal is making sure that everything's starred. What I've found here lately, like the last like 2 jobs we've done for retrofits, because we always do this in stages and we add boards. And what I've been doing is I found Wago DIN rail splitters. So it's 2 lines in, So 2 Wago lines in, because they only want using Wagos to splice. So 2 lines in, and it splits it out 5 ways each side. So I can grab in the rack, I usually bring 2 stars in the rack. I'll bring it 2 different ways, and then I'll bring it out to the condenser from there. So I'll have 2 stars in there. And then I go to the next rack from there, and I throw another Wago splitter in there, and I could split off that way. Yeah, I seem to have much better luck doing that than I do other stuff. And then ferrules. When I started using ferrules, a lot of our comm issues went away.
One of the other things that I was reading through at one point is this stuff where you can only have, they're saying that you only can have X amount of nodes on a length of wire as far as like the power and stuff. Cause essentially what it's going to do is bring down your power. Right.
Yeah.
And a lot of the boards, just like on the CPC, also have to be center tap from my understanding.
No, it depends. What it's going to be is, if it's a 500 board, generally it's going to be center tapped. So it's center tap. It's a 15 volt or a 12 volt, depending on what it is. So it's a center tap transformer.
Yep.
And that's a 500 board. The 700 boards do not require a center tap transformer. They require a standard, just 24 volt transformer. So they're a lot easier to work with. A CPC transformer will work in a pinch. So it will work. It's just, you should use the microthermal ones. Be very careful wiring them because they're confusing on the center taps, especially they're like bigger ones. There's 6 or 7 terminals on there.
Is it like the old Comtrol transformers where there's like 400 pins on them?
Yes. And they're bigger screw ones. And it's weird. So it doesn't go straight across like the backside of the top of the transformer where it's common 208, 120. Then the next one's like 480 down. Then like it zigzags like this, not across. So it's very unclear in the wiring diagram. But you want to, for 500 series stuff, which they're getting ready to end the life, I think, you want to use center taps. And don't use them on the 700 series. I learned it the hard way. I spent 4 hours one day trying to figure out why random boards wouldn't work on like a compressor chain. And of course, my dumbass didn't check voltage because everything was lit up. And I only had 16 volts at the board.
Oh, shit.
And it was enough to light it up, to read all the transducers, to some outputs would work randomly, some outputs wouldn't work.
I guess probably the more outputs we're calling at the same
Correct.
time, and they wouldn't work. Because like
Correct.
you look at it, people don't know this. They think that the voltage going into the board on the CPC on the actual relay portion is actually part powered in, it's doing the actual coil. And if you look at those relays on the CPC stuff is actually 12 volt DC. And the way they can do that is because they use the center tap, it splits the voltage, it gives it 12 volts on basically because you're center tapping it. And then in turn, it has a rectifier in there that basically is turning in DC voltage.
Correct. And MT is basically doing the same thing. So it was just enough where it would work until you got most of the compressors calling, then it would freak out. But like, that's one thing, is making sure the voltage is right, going back to square one with that stuff. But for MT, like if you really need to get down and dirty on the comm loop, you need an oscilloscope. And I just got one to start playing with these. Like I got this cheap, it's an FIN.
Wish.com one.
Yeah, IRST. For what it is,
it works.
I mean, it works. And it's a 2-channel scope, so you could hook up to both comms and you could do it with that. And it seems to be somewhat like nice for, it was $100. So I'm going to use that to start like looking at this, and I'm going to try to build a baseline of what it's supposed to look at. I was going to talk to some of the MT guys to see if like they had like pictures of what the oscilloscope should look like and what it should look like on the graph. I've been playing with CPC, and you could watch it. Like you could watch it go up, down, up, down, up, down when the TX and RX lights flash on the E2. So you could actually see it, and it's pretty cool. So I'm watching it on a comm network with one board. So I should have the best comm ever.
I wanted to ask you about this because I've never seen this on a microthermal, where you basically have a capacitor and what looks like a resistor in parallel with each other. and then going straight to ground.
I've never seen that. There are things called lawn savers.
Mm-hmm.
So those, what's that?
Lifesavers.
Yeah. So lawn savers are awesome. They help cut out some of the noise.
Mm-hmm.
I don't remember the part number offhand, but they're called lawn savers. If you Google them, you can find them. They look like a circle, and there's a bunch of copper coils wrapped around it, and it's like a choke to cut out some of the noise.
Almost like the ones that are on the blah 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 the VFD shit to stop with all the noise.
Correct. Same theory.
I think did they call it like a Faraday ring or some shit like that?
Yes. So something like that. But so it's on there, and they do help. One thing I do see that gets missed at a lot of stores is I think it's a 50. Oh God, it's either a 52 or 58 ohm resistor. I forget. I forget every time. But like, there's a resistor on there, and it comes in a little white box. It looks like a phone connector box, and that resistor needs to go in the middle of the network. It gets missed all the time.
Like when you say the middle of the network.
Is as centered in the network as you can possibly get. It's never going to be perfect because it's a star. So like the most center part of the network. So you got to look at your network and you got to decide where you think the center is. So generally at a Costco, for example, I usually choose the pump skid if it's a glycol store.
Yeah.
Because generally that's more in the center. It's in the middle of both racks, and it's in the middle of the condensers, and it's in the middle of the panels. So generally that will be as centered as you're going to get.
Yeah.
So that's where I'll usually put it in. And I usually mark on the next to the node. I'll put a little note, and it'll say resistor on at board 101.
And what ohm resistor is that one?
It's either a 52 or 58, I think. I don't remember, but it's a specific resistor for them. It's a like super high quality resistor.
Precision. So if anyone doesn't know what that is, so on the rings mean something on the resistors. Each color represents a value, and usually resistors are typically like 5 or 10% off. Precision resistors are like 0.0 something really small. So if it's 120 ohms, it'll be literally 120, maybe 0.001. You know what I mean? Like, it's very precise.
Yeah, they're expensive too. You have to get it from them. You're better off getting it from them. I wouldn't trust your run-of-the-mill Amazon ones for that. But if you start seeing high resistance, which is generally what I see more than anything, high resistance or low resistance. So if you start getting like 64, 70-ish range, you have a problem. So you have something, either you have bad wiring, you have stuff shorting out, or I'm sorry, you have stuff touching, you have bad connections. I see a lot. So that I started using ferrules on everything. So I put these crimp-on ferrules on the wires, and I have they're double ferrules. So they're double 16 gauge ferrules. It fits over. You crimp it. It fits both wires in a 1/4 inch like jacket, so nothing can touch them. And it's a lot stronger, and you get a lot better bite on the board. So it seems to have a lot less issues. So I use those a lot. And when I'm doing those, I seem to have a lot less problems. So those are what I see a lot of.
Stop messing with the code.
Stop it.
I hear it dinging. I know what you're doing. Unbelievable. Never gonna get anything done. Freaking jerk. You also have this to go off of. So you have DC resistance off the cable. I actually have a capacitance checker, which will actually tell you how many picofarads that the cable length is based off of. I think it's usually like per 1,000 feet or something like that. So I have one that you can. All right. So if you measure a sample, like if you don't know what the capacitance of the wire is, you can take a sample of maybe, I don't know, 100 feet and see what that is and see what that resistance is and figure out, okay, we can estimate that this run going from here to this case controller is going to be X amount of feet, and then figure out what essentially how much either capacitance or resistance you have. And I do the same thing with if you suspect that you have some sort of cabling issue. You can do it one of two ways. You can, because you want to make sure that the wires are not shorted anyway. You could ground out all 3 cables at the very end. Now, this requires you to unplug every single case controller. But at that point, if you've already extinguished all the things that you were trying to do to figure this out, this is sometimes the only way you can do this. Or stop it, or turn off your volume. One of the two.
It was off. That actually wasn't that. That was something else.
So what you do is you short all 3 ends, and then you start at basically at the end of the loop, and usually you'll get 0.1 ohm, right? And then you go to the next one and you get 0.2, and you have to be checking it from shield to ground. From shield to negative and shield to positive throughout the whole way. And you should get even resistance all the way through. At one point, you might get a spike in resistance on the right-hand side, indicating maybe Kevin didn't make a ferrule correctly, or there's a loose connection on that side. And then you can pinpoint where you have that abundant amount of resistance. The other thing that you would do is, while everything is separate without a terminating resistor on the end there, you could basically then measure your resistance from the shielded wire to the negative and the shielded wire to the positive, and essentially measuring that up and making sure anywhere you're not getting any type of resistance. Because if you are, then that indicates that the wires, in fact, are shorted within the casing, which can happen. Mice are awful.
No, yeah, mice are a huge issue with that. I've been seeing them with the Ethernet cables a lot with SE3s and stuff. We're starting to see, as the cases get a little bit older, the mice are starting to wreak havoc on the Ethernet cabling.
Mm-hmm.
So that's one thing. Ethernet cable checker, guys. I know nobody wants to be a data tech, but those days are over. I have a cheap Klein Ethernet cable checker I use for everything. Make sure that you guys get a decent one. You're gonna need it, and just checking cables. And then I actually got these Amazon splicers. So it's a female to female Ethernet connection. So when I'm troubleshooting SE3s or CC200s, and I think I have an issue with one case controller and it's bringing down the comm, I just unplug both Ethernet cables and I plug it into the splice block. And then that allows the comm network to continue on without having to do jumpers, but Ethernet jumpers. I think that works awesome. I've had really good luck with them.
Yeah, usually what happens is, unfortunately, with the coffin cases and some of the other cases, they run these case controllers underneath the case. And let's just say one day they might get wet. And that I used to do a lot of cell phone remanufacturing when I first got out of school for engineering. And we used alcohol and shit to clean all that stuff off. If people drop their phone in the toilets, cow poop, that name it. Like I've seen like a whole bunch of phones that come back in warranty that are in bags or pieces or whatever. But sometimes you won't see very much blinky on the green and orange lights, usually indicating that there's some sort of issue. So what Kevin's saying is basically just bypass that controller if the one that you suspect is maybe bringing down the comm loop. I've had luck temporarily just to get the comm loop back up and running by pulling apart the case controller, because the covers come off pretty easily on most of those case controllers, and just taking rubbing alcohol, obviously with power not applied, and take a small brush that you would use for putting soldering flux, like a small flux brush, and use that with rubbing alcohol and get all that white crap that's now in between all the pins. Those pins are really teeny tiny. And so all it takes sometimes is just cleaning out some of that debris within each one of those pins and letting it dry off. The rubbing alcohol is going to evaporate. Put it back together and see if you're good. Because otherwise, the customer is going to be pissed that it's not reading, and they want it up as fast as humanly possible. But what Kevin was saying about this little checker here, it'll actually tell you if it's wired properly. So in case you cross the wires by accident, because all these wires essentially have to be within a certain, they have to be lined up perfectly, and there's 8 different wires, so it's very easy to screw that up. And it will tell you if you have a short or a splice or an open. Did someone make it as a crossover cable? So when they looked at it this way, it started with orange over here, and then when they looked at it this way, it started with brown in the same position. And sometimes that happens too. And so usually there's a little piece that comes out of the bottom of these things. Oh, here, actually it shows it right here. So there's a little piece that comes out of the bottom there, and it's basically checking to make sure that this thing is lined up. So you can see in this one, 1 for 1, 2 for 2, 3 for 3, and so on and so forth.
Oh, sorry, I was still muted. No, that's the one. That's the one. That's the one I have. That one works pretty good. The only thing that sucks about it is it's really easy to lose the little piece. It's really. I have 4 of the like connectors in my, or the main ones in my van, and I've lost all the little pieces for them. Yeah, because like you leave it, like you unplug it and you like set it down, and you're like, oh shit, where'd it go? But it's not bad for what it does. Okay, so it works pretty decent. The slightly more expensive one is a little bit better. I will say this though, if the electrician's doing them, good luck, because they usually screw them all up.
Can't do one podcast without you bashing those poor electricians. That
Yeah, the problem is they don't do that a lot, and I'm not the best at it either. Like if you don't make, I'm getting better at it. If you don't make a lot of Ethernet cables like every day, you're not be good at it. Get the Klein pass-through ones. Don't even waste your time trying to be cheap and not getting the Klein pass-through ones. Get the pass-through ones. They're so much easier.
Yeah. When I did my first store that everything was communicating Ethernet, you try to run it and you waste time and time trying to get this thing rolling, and then you're just pissed off at yourself because you screwed it all up. Here, 1%. You can see like how much it's all these little itty bitty wires. You know what I mean? Making sure you have the right length. So with the pass-through ones, because they have a stripper that you're supposed to use for it. Her name's Bubbles. No, there's a stripper that you're supposed to use to pull off X amount of the wrapping and casing. And sometimes, honestly, it's easier to extend the wires out way longer than what you need. And then by what Kevin's saying, having the pass-through ones, basically the wires will actually stick out the front of this. And then I think the new ones, they cut it off the end there, correct? Kevin, you're muted.
I was unmuting. Calm down. The good Klein ones will cut the wire off the end.
And then this right here is the orientation that you could be. So the 568A and 568B, and usually on the prints, they'll tell you where they want them, like how they want every single one of those wires set up. And that's just the orientation here between what color starts where.
Yeah, no, it's a lot easier with the pass-throughs. Just make sure you're making your Ethernet cables and check them every single time. I see more guys frustrated trying to figure out comm issues with an island. Like I'll do a cable, I'll do both ends, I'll put the checker on there, make sure it's good to go. And then I'll move on to the next one. And then move on to the next one. With the Ethernet cable. And then there's also like ping tests. Like I had to do this the other day with Copeland. So what we had to do is what's called a ping test. So you basically take the first SC or first controller where it only has one Ethernet cable going to it. And what you're going to do is you're going to hook your computer up to it, and they're going to give you a list of IPs, or you're going to figure out what all the IPs are. So they're going to give you a list of IPs. You're going to put it in this range. You're going to use this program. And what this program does is it's going to just keep pinging packets of data to all these IPs.
Is that Yabe?
No, it's not Yabe.
Wireshark?
It was Wireshark, I think.
Right,
something like that. But
no.
I'll have to look at my computer to see what it actually is. It was off some sketchy website.
It's Wireshark. I'm going to bring it up right now. I was downloading it the other day, and I don't know. I haven't gotten it. Actually, I could probably do it while we're talking. If I hook up the E2, I could ping that, correct?
Maybe. I don't remember if it was Wireshark. It may have been. So it may have been Wireshark. I had to look at my laptop because it's on my laptop. But what we did is we did this test for 10 minutes.
Mm-hmm.
And on this test, at the end, I'm trying to see if I can find it in my downloads. On this test, what it did is it gave us, okay, here's the comm statistics. And it's right here. We have this controller had 15 errors. Okay, every other controller was good. And then this controller had 10 errors. So in between, say, A1C and A1D were these comm errors. So you could see where the errors started and stopped. So it gave you like a baseline of what controllers to check to go through Ethernet cables or check the controllers themselves to see what actually happened.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Gotcha.
But that took a while, and the only problem with it is you need a laptop. But it was a good tool, and you could use the same thing for the SC3s.
So right now I have this thing hooked up to the KE2 controller that's sitting right next to me.
Okay.
So
you should be able to do it.
Okay, go ahead. Tell me what to do, because I've never used it yet. So I have it on local area 9. So when you first boot your computer up, once you plug it in, so mine unfortunately doesn't have a Ethernet. All right, my laptop does, but not easily enough for me to roll around real quick and get this rolling. So some laptops do not have an Ethernet cable. So I actually have to use a USB over, right, to Ethernet. So I should be able to, Ethernet to public network, and that is Ethernet to properties. I don't have to do anything with TCP, right? Nope. Yeah, USB 2 to that.
So we had to put the range in there. We had to make the actual, like, in line with the controller.
Yeah, this is where I was struggling, because I couldn't figure out what the IP was the other night when I was cursing your name. And I was like, man, I couldn't figure it out. And obviously I don't have the IP because it's not really sending and receiving enough packets here. So
correct. So that was the one issue. So like on the actual like CC200, like when you're logged into it on the app, it'll tell you the IP address. So even if you're set up for backnet over IP, or once you set up the instance ID, which is so like the case ID. So if it's BS, it'll be like 11 and say it's 9, circuit 9. So BS 009, and then if it's A, it'll be 1. So BS 009A be 1. Okay, that's going to also set up your IP address in the controller also after you display wherever the range is, but it auto does it for you. So that's going to set up your IP address. So you have to make your laptop off from those IP addresses, just like you would be connecting to an E2. So
it looks like I'm actually receiving packets now, so I should be able to.
Really?
Yeah. So here, look. Damn it. Right here, Ethernet 2. See, now I'm not receiving, because I was received packets and sent. It's just being dumb now. But I'd think that hopefully I would be able to. It's not showing any. That's the thing. It's not showing anything for 9. It's using the Ethernet, which is obviously what we're broadcasting on right now. Adapter for loopback. I'm not that smart to understand what that is, but basically I should have some sort of traffic on this local area 9 if it was actually working.
Correct. You should have some traffic on there.
And then what do you do from here then?
This is a completely different program than what I had, so it wasn't Wireshark.
Okay, never mind.
Yeah, I'll have to look at my computer and figure out what it is, but my laptop takes about like 15 minutes to boot up because it's a giant pile of crap.
Yeah, the only other ones I have is Modbus, Pole, and the Yabe that you told me to download the other day.
Yeah, which they could all be used for stuff like that. But to be honest, like using that ping checker was like a latch ditch effort to figure out something. So that by that time, Copeland is probably involved, and you could do the same thing for the SC3s. You could use that ping checker for stuff. It's the same setup basically.
Yeah, it's going to tell you like which unit's basically dropping packets, which one's not communicating the best on the network, which could be the potential issue with what you got going on, whether it be a loose Ethernet cable, could be a bad Ethernet. Typically, it's usually either a bad Ethernet cable or water. Would you agree?
Yeah, no, most of the time it's water. No, like, it's the same thing. It's the same thing that like me and you were talking about. Like you were just talking about. It's the same thing over and over time. It's the coffin cases and the single decks where they get wet, and it's usually on the SC3 controllers. It's the very right corner above the Ethernet cables on the board is where I generally see the water get in, and it leaves like a white calcium on there. And as soon as if you clean it off, you could usually get it back going.
Mm-hmm. So someone was telling me, oh, was it? So they make, and I haven't tried this yet, and I wonder if it would actually work. There's some sort of spray that you can put on PCB boards that essentially puts a coating on it that it makes it a lot less susceptible to water.
Really?
Have you seen this?
No.
All right, bide some time up so I can look this up real quick. But yeah, I forget what the hell it was called. It looked almost like a ShamWow commercial. You know what I mean? Like, just throw it on there. It works.
I guarantee there's got to be something because there's stuff in random like environments, like just harsh water environments where this stuff's gonna happen. But I got an idea. Like, how about we like not mount the boards right underneath like where the wires all go?
What are you gonna do though?
I move them to where like the other side where the wires aren't going in,
where the drain on the other side of the damn drain. You know what I mean? Oh, here it is. It's on Amazon. Everything's on Amazon.
Is it ShamWow? Is
It
a ShamWow guy in there?
It literally looks like a ShamWow type thing. I swear to God. Hold on, give me a sec. ElectroSeal electrical waterproofing spray on clear protective rubber film.
Is it like does it like conduct electricity though?
I'm assuming not. Electrical panels, circuit boards, battery terminals, wire connectors. Doesn't that look? It's called Ducky. Doesn't that literally like just be like, it works on this. It works on this.
Really?
Yeah, look.
It is.
Holy shit. That's crazy.
If it works, but what are you gonna do? As a PM, start spraying all the boards down?
Imagine how many communication failures it would fix.
Yeah, okay. Yeah, but by the time you probably could have paid for it if you take for like the entire year taking off the bumpers.
What is this called? It's called Ducky Marine. It's for RVs. And you know what? That kind of makes sense though. You have the salt water and all that other shit affecting a lot of the electronics on these boards, right? Dries crystal clear, provides electrical insulation, prevents corrosion and moisture. The only thing I'd be freaked out at, what's it going to do with the chipsets, right? There's no fans on any of these chipsets, right? Would that essentially insulate them and cause more heat?
I would think so, probably.
Extremely flammable under pressure.
Extremely flammable.
Fatal if swallowed. Vapor harmful.
Okay, so the window lickers are going to end up killing themselves.
Oh my God, you are the most absolute horrible person in the world.
What? Some stupid person is going to be like, oops, I got it in my mouth. What?
It's amazing.
It's let me guess, and it is also illegal in California.
That was actually the other comment I was gonna make. I'm like, and causes cancer and birth defects in California,
but only California.
So they have this other thing too. So this is RectorSeal, right? Which is we use RectorSeal stuff. Conformal spray coating for circuitry. That actually looks a little. That doesn't look as ShamWowy.
I trust the RectorSeal stuff more than I trust the ShamWowy stuff.
than something called Ducky.
It's just Ducky. But it's that's a huge issue with that is the water.
How many calls have you had where it's that?
A lot. We had a Sam's Club, dude. It was like every other week.
It's part of the reason is because sometimes you have the meat manager that basically is, we'll just dump 20 gallons of water.
That's what it was, and I was ready to fight the guy by the end of it. I'm like, dude, please stop spraying. Like, it was to the point where like I had taken butyl. And it just looked like I was just smashing it down where all the wires went. Like I was over there with a trowel and like a gallon thing of butyl, just like slapping around. And because it was like, no matter what you did, like we were sealing brand new cases because it was like I was filling cases with water, filling them up, and then putting dye in there to figure out where the water was coming down at.
What potential hole is
But it was because they were just like, just sending it with the case cleaner, and it was just ridiculous. It would flood every time, and it's like, dude, how much water are you guys putting down here? It's great you guys are actually cleaning the cases, but what is going on right now?
And it's always, every single time, it's always right at the Ethernet side.
Yes.
I don't know what it is.
Well, because they bring the wires, it's in that particular manufacturer, they bring the wires down that one side, and it like they leave 75 feet of wire in there, like you're gonna move the case controller to the other side of the island.
Yeah.
And all that wire just literally runs down like a little snake. And then it just fills up the trough, or it goes down and just drips perfectly in that one spot.
No, that does.
It's so frustrating, and it's not the case controller manufacturer's fault or anybody's fault like that. It's just it's a bad place to put them. Like it just really is an awful place. Case controllers don't belong under cases, but there's nothing you can really do to stop it besides building something on top, and it's going to look funky. Or honestly, like I would think like a front rail, to hide it. I think Kaiser does a pretty good job with the way theirs drop down.
Mm-hmm.
The wires are back farther in the case, so where it drops down, so the wires are actually exposed a little bit underneath the case, in a separate trough almost, so it can't really drip onto it.
Has like a secondary like catch for all the moisture and such.
So it doesn't really go in there, but then I also think like that case controller is warm, and it's just like attracted to it. Like it just wants to go to where it's warm. I don't know. There's no real fix to it. But as we're going farther and deeper down in this case controllers, like guys, it's more imperative. And I want to go over like the KE2 stuff now and like the CC200 stuff where you're looking at backnet instance IDs, which we went over this before, on how to tell what these are, like the addresses are. Like if you're doing CC200s, for example, like when you're first bringing them on, I've had like multiple stores where they aren't programming the E3s. So like the rack manufacturer programs the E3, comes out, they didn't do the cases. The CC200s are supposed to come out pre-programmed by the case manufacturer. It's 30% done usually. So yes, like today I started up a bunch of them, and to be honest, this is the most programming I've seen. Like they all had a program in them to a point, but it wasn't nearly what it should have been. Like they weren't complete. There was incorrect defrost time, stuff like that. So you need to go through and make sure everything's right. Make sure all the valves are the correct ones. Make sure the valves are landed on the correct drivers. And then what you do is make sure all that's right. All right. And then what I do is I write down the backnet instance ID. So if it's BS 09 or BS9A, so that's going to be 11.009.1 is going to be that backend instance ID. Okay. And you're going to write down what the case is, how it's worded in there. If it's BS 09A single deck meat. Okay.
Are you doing this in like not to sound like an asshole, but an Excel spreadsheet to basically to label it out? So
I'm going to start.
Okay. Are you going to automate it? Are you going to connect with Wireshark and bring back all the instance numbers and then have it formulate via
You don't have to. The E2 is or E3 is going to do it. Standing with, but fuck you. Maybe you're on this other rabbit hole, and now I'm going to be stuck doing that for 16 hours.
16 hours.
I hate you right now so much. And now I'm saying now I never say that. So, you're such a dick. I swear to God. Such a dick. Like, now I lost my thoughts. All right, I write these down as I'm going. So that way it's a little bit easier to troubleshoot later on. And I also write down the Ethernet address. So that way I have it. Now, when you go into the E3 and you add the CC200s, I add one, and then you go to the control inventory, and then you just multiply it. You can tell it how many you want to add. So if you want to add 15 of them, okay, You add 15 of them. You go to your first case, and the case that the RS-45 goes to, you make that your router case. And in that router case, there's a max masters. You need to set that at whatever cases you're going to have. If you have 35 cases, set it to 35. It's usually
explain what a router case is?
So the router case is going to be your first case. So that's your RS-45 to where your Ethernet chain starts. Just like the SC3 at Novar, when the Novar stores it, it's usually the one that's address 7. It's the one that with like a normal address in it, not like the hieroglyphics. So it's a normal address. But in the CC200s, it's whatever case starts to be in the network. Generally, what they're supposed to be doing is in the description of that case, the CC200, it's supposed to have an R next to it. So if it's BS01A single deck meet, it'll have an R next to it at the end. And what that R signifies is going to be your router case. So now I believe that's going to be going away if it's all Ethernet, because the router would be the actual
E3 probably, you know?
E3 or the router in a store.
Unless it's it. Yeah, because you have in and out on all those, right? So you could potentially go in and out on every single one. What I'm wondering is, so I'm actually leaving. I'm getting on an airplane on Friday, so I'm not going to be around the whole weekend. But what I'll try to do within the next week or two, I'll wire up that CC200 that I have. I'll get a license from someone from somewhere else. And
I have all that, but I don't have a screen to address it.
I know you keep saying that, but what I'm saying is I'll get that all rolled out, and then we could do one live here and like actually how to communicate it. I'll set a camera up on the screen that I actually have, and then we'll get it rolling up. You know what I mean? And have it communicating, whether it be, do you want to do the E2 or the E3, or we can actually do both?
Let's do the E3 because it's a lot better setup. The E2 is janky with it. But honestly, it's so simple. Once you get all the CC200s made, don't worry about naming them. Don't worry about programming them. So what you need to make sure is it auto sets up is it pulls data from the CC200 first, just like you would be if you were doing like core links. So you want to pull that data into the controller first. You don't want to push data out unless you have blank ones where you're doing all the programming on the E3.
Yeah.
Then that's different. You need to switch it and set it up. But it's going to pull all that data in for you. So it'll start pulling. It'll start checking all of them. And it'll say, okay, I'm going to go out there and I'm going to ping all these controllers. It says, I see 6 CC200s. It's going to come back and it's going to display 6 addresses now. It'll say 11 0091, 11 0092, 11 0093. So that's going to be BS09A, BS09B, BS09C. So now all you got to do is go into that CC200 and rename it. So you're going to name that one whatever it's called in the wording in the controller. So it's going to be BS09A, BS09B, BS09C. And then once you do that, your CC200 is renamed and it shows up on the refrigeration screen. That's all you got to do to bring these in. It's so simple.
Does not sound it.
Oh, it's great.
No,
So,
I know. You need to get me that.
Yeah.
What you need to do is get me the what ping checker that you're talking about, because I would have loved to try to figure out what the hell the IP address is, because I literally was up until 2:00 in the morning trying to figure out what the hell this IP address was, because I put the one in there that was in there. Then when I set up the TCP4, and if someone doesn't know what the hell I'm talking about, so you pick wherever cable you're actually connected to, and then this little pretty thing shows up. And then when you go to properties, here's your internet protocol version, TCP version 4. Open that up. And typically all you need is the IP address, and then you need your subnet mask. So the subnet mask is that number that's usually 255 or 255, 255, 255, and then 0. And then the IP address is not the actual IP address of the controller, but you have to actually you can't be exactly at the same address, because this is basically making the computer the same address as the controller. It's, I'm trying to talk to something that has the same address as me. You know what I mean? It's like trying to give yourself directions on Google Maps, where you just end up having to go to the same place. You know what I mean?
no, yeah. It's incredibly important to make sure that you're really diligent about marking this stuff. Like especially when you're doing these remodels. For example, we're doing a store right now. They call for the router case. This is where it gets sucky. They call for the router case to be installed middle of the remodel and the prints. The whole con loop changed.
Oh, that's dumb. And that's where this is right here. So it says configuring of non-routers CC200, blah, 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 blah. So that's I just saw it. Oh, RTR. So the only one that you're going to set up for RTR, basically router, is the one that everything's going to feed through where your 485 starts, which means what you said, Kevin, you might not get that case that it was originally anticipated right off the bat.
Correct.
What they need to start doing, like with the engineering, is if they're doing the remodel and we were doing a CO2 system, then it has to be one of the medium temp circuits that is going to be that damn router case. You know what I mean? In the scheduling of what they're doing first, right?
Yeah, that's a big thing, but it never works out that way. It just doesn't.
Are you coding again?
No. Maybe. No.
Son of a bitch. Right.
So yeah, it never works out that way. So like, just make sure that if you change it, make sure it gets updated and it's all on there. I like to put it on the print and then make sure that it's updated in the controller where it actually shows, hey, this is the router case. Like this is the number one thing. That's what I've been seeing it miss with these. And the KE2 cases are the same with Novar. You make sure that like with KE2, everything has to be worded exactly the way it is inside the Novar controller. So if you go to Backend Network and it's a capital M, capital D, capital M for meat, and then lowercase, it has to be exactly that way or it will not come online.
Do you have any of those prints, by the way?
I don't, because
How do you not? All the jobs you do.
The KE2 ones, they're like, it literally is like a one-line diagram and that's it. And it just shows it going into one case and out one lineup, out the next lineup, one lineup, out the next lineup. That's all it shows.
You know what? I was actually looking for something today and I accidentally found that and I was like, oh, I got to remember to show that. And then it like shut down my computer and that just didn't end well.
It's frustrating with that stuff because it's very hard to make that what it is if they don't give you the actual schedule, the print. Then half the electricians don't follow the print anyway because they know.
I don't know why though. Like it makes it so much easier for everyone to diagnose later.
Because they don't give a shit. And when they're pulling the wire, here's the thing. These architects and engineers are not looking at this. And they're not looking at how this is set up. So what's happening is they're looking at it, okay, this case is A, this case is B, this case is C, whatever. It's lineup 1, lineup 2, lineup 3. Lineup 3 may be 200 feet away from lineup 2, so it may make more sense to go this way. So that's what happens. I get it. It may cut down on the wire runs tremendously, and it may make it better, but it makes it harder to troubleshoot when it's not documented. But that's where the engineers need to come in and actually look at this and be like, okay, to run from here to here is going to be less work if we go skip over that case and go to this case first. Some of this stuff makes more sense if you're in the field looking at it in order to like run wire everywhere for no reason. I've seen prints where it goes front store, back of store, front store, back of store, because the engineer literally looked at the print and went 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. Yeah, he took about 4 seconds looking at this to make it.
I think you're being hard on him.
Shut up.
Damn it. Maybe I'll be able to. I should have just saved it. Usually when I find something, I'll save it right to the desktop. But I've been going through so much stuff, like so many documents here late, like looking for stuff that I'm working on, and it's a cluster.
Yeah, everything is a cluster. It's I don't know.
Oh, I think I found it. Oh shit,
Squirrel.
I think I just found the layout because I was going to ridicule you earlier, but I didn't. And then
I've had a rough day, and you're being a dick.
No, I'm not being a dick. Yeah, see, all it has is the line out for these, right? So, what you'd have to do after I share, because I'm an asshole. Here we go. Let me zoom in a little bit. So this is what they typically look like on the Walmart prints, right? So you have, so this one BS4, BS5A, BS5B, BS6A, 6B, and so on and so forth down the line. So then you have to, and usually what I'll do is I'll run over to Mia and then mark out which cases go to where. So like I would take a highlighter, right? So the ES1 typically is in the rack houses, right? And then so it looks like they had how many comm loops? 1 and 2. So they have 2 comm loops, right? 2 comm loops as far as the KE2. So then what I would do is start wherever it's going to. So you probably have one for C and one for A and B, and then just draw a line and go, okay, so BS4 goes first, and then it goes to BS5A, and then 6A, and then 6B, and then 6C, and then 6D, and just roll through like how it actually is laid out, which a lot of times will actually help you figure out your comm issues. I know in the doesn't the ES1 kind of tell you like how many if there's a setting in there somewhere where you can actually see
only on your computer?
Really? See, I thought there was some kind of packet thing for errors on there.
Yes, on your computer. If you're on a computer, you could see that. Now, if you're on the ES1 screen, you can't see it because you could only see like barely any data.
Yeah. But back to what I was saying. So you basically draw this out. Your 45 lines coming off your COM2 for your cases for this side right here. And then COM3 is going to all of these beautiful, lovely cases right over here. And so you can see sometimes if these ones are losing information, you could assume that something's going on over here. And what Kevin was saying is if you suspect that, let's just say this case controller right here, wrong way. BS6D is the one that's giving you shit. You could essentially take that little jumper, which is female to female Ethernet connector, and just right at the controller itself, bypass it.
Yep, that is literally the easiest way to do it. Like that is how I do it on all of them.
So I have a question now though, because the KE2s don't have an Ethernet in and Ethernet out. So is this even right?
No, because you need a router for each. This is where this issue came up in this job we're doing now. Is they call for a router for every lineup.
Yes,
but obviously that wasn't provided.
Something that looks like this. I think this one right here.
Yes. Yep. Just a small little router. It could be even like a Linksys, like a small little Linksys. It just needs
EM plus with BACnet. But yeah, that's but so I was talking to someone the other day, and I know we got to button up here, but I was talking to someone the other day, and they said that there's actually there's a way to do Wi-Fi like linking them together, which seems, I don't know how I feel about that.
Yeah, I was told the same thing. They're like, "Oh, why aren't these Wi-Fi linked?" I'm like, "Oh yeah, where's the steps to do this?" Oh yeah, there's no manual.
Yeah, I'm still waiting for that too. I talked to a guy the other day. He's, I'll see what I can come up with. Yeah, he's one of our good friends who's been on the show before. Is now in sales, and yeah, he doesn't belong in sales. He does, but
he's too smart.
Right. So
just a giant waste.
Yeah, it is.
But no, it's that's one thing that needs to be addressed with that. It's their manual is to be desired, if that's what you want to call it.
I don't think is it really a manual?
It's not really a manual.
One of my presentations, just like throwing shit on screen doors, just a little bit of this, a little bit of here, a little bit here.
Hey, look, the defrost scheduler is working.
Mother of Christ. I'm not working on it. I'm not working on it at all. On that note, we're going to go. You guys have a good night, and we'll talk to you guys soon.